Welcome to Lesson 3 of the USB Network Gate SDK tutorial. In the last lesson, we set up the server application and retrieved the list of devices on your computer. Here we'll talk about how to actually share those devices so the client application will be able to connect. We'll also go over some more advanced configuration options for the server project so you can establish device connections that are encrypted, compressed, and authenticated. The first thing we'll do is modify the rebuild tree function to fill out a little bit more information about the retrieved devices. Now, after calling the constructor, we'll also retrieve other properties from the SDK and set them in the new object. For example, we can call server USB dev is shared, passing in the UNG context pointer and the device pointer, and it'll return a Boolean that indicates whether or not the device has been made available for sharing. We'll set the device's isConnected property in a similar way by calling server USB dev is connected. We also want to display the device's status, so we'll write a little utility function that provides a human-readable status string. The actual SDK call is to server get USB dev status, which outputs a status integer and the connected hostname if applicable. The U2EC C# file defines a few constants that cover the range of statuses, so we'll simply need to compare the status integer to those constants and return an appropriate string. If you recall from the last lesson, we added buttons on the main window that allowed us to toggle between displaying all ports, ports with devices, and devices that are shared. And here is where we'll do that filtering. All we have to do is perform a switch statement on the selected display mode, and we only add the device into our USB hub if it meets the display criteria. For example, if we just want to display devices that are actively being shared, we only add it to the device list if isShared equals true. Now when I start the program and share a device, I can toggle between showing all ports, just the ports with devices, and only the devices that are actively being shared. In addition to these specific functions for determining whether a device is connected or shared, there's also a generalized function called server get USB dev value by name that allows you to look up values for a device by attribute name. These values include things like device type, connection status, whether or not the connection is encrypted, and product ID and vendor ID. The function takes the UNG context and the device pointer as inputs, and outputs an object to hold the returned value. To make things a little easier, we'll wrap this in a utility function within the model that will just take the device context and attribute name and look it up using the context pointer stored in the model. Now we've got a convenient way to look up device attributes. We'll do something similar and add a utility function called getDescription, which just calls this shorthand function and looks for the attribute called USB class. It then calls its own overload, which takes the retrieved string value and just performs a large switch statement that gets you a device category like audio, imaging, or security. We won't go over all of these device categories in their codes, but they're all available in the sample project. There are plenty more device attributes you can retrieve and modify, which we'll go over in just a bit when we cover sharing devices with custom settings. First, however, we'll share a device and just use the default settings. The code to do this is incredibly simple. We can set up a function called share that just takes a USB device as an argument, and then all we have to do within that is call the SDK function server share USB with predefined values, passing in the USB network gate context and device context. If that returns true, then we update the device's isShared flag accordingly and update its displayed status string. Otherwise, we'll alert the user about a potential error. Then we can set up an almost identical function that makes a device not available for sharing, which looks pretty much exactly the same, but calls an underlying SDK function named server unshare USB dev. Finally, we add this toggle method that chooses whether to share or unshare a device based on its current status. And then, when instantiating the device, we assign the toggle function to its toggle share command. Then I'll start the program, pick a device from the list, and hit the toggle button to share it. When I hit the button again, the device becomes unshared. Next, we'll talk about sharing devices with custom settings enabled. We've added a pretty simple user interface window called Sharing Options Window, as well as an underlying model to support it called Sharing Options Model, that lets you select and input different properties for the device. Sharing Options Model essentially just stores a collection of different device properties that we'll display in the window. It also inherits from the Observable Object class from Lesson 2, so it can notify the UI when different properties change. The constructor takes in a host name and a connection timeout and sets those properties within the class. The UI code for the new window is straightforward, so we won't go over it in detail. Instead, I'll just show you what that window looks like. So in addition to the share and unshare functions, we'll add another one called Share with Options. This will also accept a USB device as an argument. Remember the utility function we added earlier that allowed us to look up device properties by name? We'll call that a bunch of times here to fetch all of the device's attributes from the SDK and load them into a new sharing options model. Be sure to pay attention to the spellings of these attribute names, since that's critical in targeting the right attribute. We can construct the sharing options model with the device host name, which is the netParam attribute, and the connection timeout in seconds. Then the attribute called nick is a device nickname or description string, and auth and encr let you know whether a device requires a password and whether the connection will be encrypted. These two compression attributes indicate whether or not the connection is compressed to save data, and also what type of compression is being used. Setting Allow Remote Disconnect to true determines whether or not the client application can decide to close the connection. And finally, the Don't Reset property stores whether or not hardware reset has been enabled. Some USB devices do not support the hardware reset and will not function after you perform it. Others cannot be connected unless the hardware reset is done, but it's something you'll have to figure out based on the type of device you're using. Now that we've created the sharing options model, we'll set it as the data context of the new sharing window. Then we'll set up a little shorthand subroutine just to allow us to quickly set properties by making a call to the SDK function server set USB dev value by name. We can call show dialog on the window to display it as a pop-up. This means that the rest of the function won't execute until the window is closed. Then, when the window closes, we call the shorthand function to set all the device properties based on whatever was modified in the sharing window. At the bottom here, we make sure that the connection's password has been set if encrypted is enabled, since encryption without a password won't work. The final step is to go back to Rebuild Tree and route the device's Share with Options command to call this function, and then ensure the corresponding button in the main window binds to this command as well. Then we can build and launch the program. Once it starts, select any active device from the list, in other words, not an empty port, and click the Share with Options button over on the right. The pop-up window appears, allowing you to choose your settings. Now when I click Share, these settings will be applied, and the device is ready to connect to a client. Then in the next video, we'll begin to set up this client project so you can actually connect these shared devices between your two applications.